Video about angles in the circle. Okay, so today we're going to solve some examples of the inscribed angles in a circle. Okay, so let's remember that an inscribed angle is the one that has the vertex in the circumference. For example, here we have the angle AB, okay, which is 42 degrees. Okay, the problem says that this is 42 degrees. This is an inscribed angle whose vertex is right here in this point of the circumference. So they ask you to find the arc AB. We need to find the arc AB. So let's remember the formula to find an inscribed angle, and remember that the arc is the double of the inscribed angle. Okay, so if we already have this angle, which is 42, the inscribed angle, so the arc will be 2 times 42. Okay, so the arc AB, if we are going to find the arc AB, we multiply by 2, 2 times 42, which is 84. So the arc AB, all of this arc, the red arc, will be 84 degrees. All right? Okay, as easy as that. This is the inscribed angle, guys. So let's see another applied problem. Let's check, for example, here we have, they ask you to find the value of x and y in the figure. Okay, so here we have this circle. They give you this angle, the angle PSR, which is 50 degrees. They give you, we need to find the value of x, we don't know how many degrees do we have here. And they also ask you to find the value of y. How many degrees do we have here? Okay, guys, so remember, let's use the formula of the inscribed angle. Remember that the arc is the double of the inscribed angle. So with this equation, we can find the missing angles here. So let's see. Since this angle, the arc PQ, they give you here the arc PQ, which is 40 degrees. So the inscribed angle that corresponds to this arc PQ is x. So we know that the arc is the double of the inscribed angle. So the angle x will be 40 divided by 2, because it's the half of the angle of the arc. So it will be 40 divided by 2, and that will be 20, okay, 20 degrees. So the angle x will be 20 degrees. All right, so here we have the angle x. All right, guys, but now how can we find the value of y? Okay, so to find the value of y, we need to find the arc QR, but we don't know any inscribed angle that forms the arc QR. So what do we need? We can use, for example, here, the whole measure. Okay, if we see at the inscribed angle PSR, the angle PSR is 50 degrees. So with this angle, we can find the arc PQR. Okay, so if we know that this angle is 50 degrees, we know that the arc PQR, let's write it like this, the arc PQR, that will be 2 times the inscribed angle. So all this arc PQR will be 2 times 50 degrees. So if you multiply 2 times 50, that will be 100 degrees. All right? So if you know that all of this arc is 100 degrees, so we can find the missing angle that we want to find, which is y. So how can we find y? If we know that all of this is 100 degrees, if we subtract 100 minus 40, you will get y, the angle y. So we know that y equals 100 minus 40. Okay, so that will be 60 degrees. All right, so we already found y, we already have x, and we finished the problem. Okay, we have all of these angles already found. Okay, guys, so these are the inscribed angles. Okay, let's see an additional example, guys. What if we have, for example, this? We have the angle PQR, the angle y, that we don't know how much is that. We are going to find it. We don't know the angle x. That's also a variable that we need to find. But here, the only data that we have is the angle QSR, which is 50 degrees. Okay, guys. So with this angle, this is the inscribed angle, we can find the measure of QR. So remember that the arc QR is the double of the inscribed angle. So the arc QR, we can represent the arc like this, QR, with this little figure. This is the arc. So the angle QR is 2 times 50 degrees. All right? So that will be 2 times 50, and that makes 100 degrees. All right? So we already have this arc, which is 100 degrees. All right, guys, once we have this angle, this is the key to find the angle PQR. So we are going to find the angle. We can represent like this, the angle PQR. PQR, remember that the inscribed angle PQR, it forms the same arc, which is 100 degrees. So this angle Y, which is the same as Y, that will be the half of the arc. So it will be 100 divided by 2. All right? So that will be 100 divided by 2. And that makes 50 degrees. Okay? So that will be 50 degrees. All right, guys. So we already have this arc, the value of y. Now, how can we find the value of x? Look at the arc that forms the angle x. This is also an inscribed angle. And the arc that forms the angle x will be the same, QR. This is the same arc here. So we know that the angle QR is the same, is 100 degrees. So what will be the value of x? If this forms the same arc, that will be 100 divided by 2, okay? Because this is half the arc. So that will be we can say that the angle QTR, which is the same as the angle x, this is the variable that we need to find, that will be the same, 100 divided by 2. And that makes 50 also, all right? So that will also be 50 degrees, okay? We also have 50 degrees. So now we already found the value of y, which is 50, and the value of x, which is also 50, all right? So we already solved the variables that we were looking for, all right? These were the missing angles. All right, guys, so these are the inscribed angles. Let's see now something really, really similar, which are the semi-inscribed angles. Okay, remember that the semi-inscribed angles are formed by a tangent, okay? The green line is a tangent, and a chord. So the chord can be AB. So we have the chord AB and a tangent. Remember that the tangent is a line that only intersects one point of the circumference. And they give you this value. They give you the value of 40 degrees. So guys, let's remember that the arc is the double of the semi-inscribed angle. Okay, it's the same as the inscribed. It's the double of the semi-inscribed angle. So this semi-inscribed angle, which is 40 degrees, that can help you to find the arc AB. So the arc AB, we can represent AB and the little arc here. So the arc AB will be 2 times the semi-inscribed angle. So it will be 2 times 40, which is 80 degrees. Okay, so if you multiply 2 times 40, that makes 80 degrees. All right, this is the arc AB, the thing that we were looking for. All right. This is really similar to the inscribed angles because actually it's the same equation, guys. We multiply by 2 and you get the arc. All right. So let's see now an additional example of semi-inscribed angles. All right. Let's see how can we find semi-inscribed angles. So guys, here we have a picture. Here we have this is an inscribed angle, the inscribed angle PSR. Okay, this is inscribed because the vertex is right here in the circumference, all right? And they tell you that this angle is 60 degrees. So how can we find this angle that is formed by the tangent QR and the chord PR, all right? Remember that here, if we have this inscribed angle, we can actually find the value of the arc PR, which is the same arc of the semi-inscribed angle. So if we already have this arc, the arc PR, okay, we already have this arc. This is 2 times the inscribed angle, which is 60 degrees. So if you multiply 2 times 60, that will be the value of the arc PR. All right, that will be 120 degrees. All right, this is the arc PR. Okay, the arc PR. All right, once we have the arc PR, we can also find this semi-inscribed angle. Remember that the semi-inscribed angle is the half of the arc, and the arc is the double of the semi-inscribed angle. So since we already have the arc PR, that is 120, so this missing angle, let's say that the missing angle is A. We can say the variable A, or you can say B, C, D, any letter. So that will be 120, the arc divided by 2. All right, so that will be 120 divided by 2, and that makes 60 degrees. All right, that will be 60 degrees. Okay, guys, so that will be the missing angle right here. Okay, let's do an additional problem. We can represent an additional figure. Let's draw, for example, a new circle. Let's say that we have a circle here. We have another inscribed angle. Let's say that we have this. We have this angle. Let's say that this is 70 degrees. And here, let's say that we have another line here. Let's change the color. We have a chord, and we can also have a tangent like this that only intersects. We can say that this is the point, let's call the point A, B, and C. We can call the vertices with any letters. All right, and we need to find this missing angle. Let's say that this is X, all right? This is the angle X. So guys, is a similar problem here. We need to check the inscribed angle ABC. The inscribed angle ABC is 70 degrees. So we can find first the arc. We can find first the arc AC. So let's find the arc AC. So the arc AC will be, think about it, how can we find the arc AC? If we have the inscribed angle 70 degrees, the arc AC, that will be 2 times the inscribed angle, so 2 times 70. So that will be 140. So if you multiply 2 times 70 degrees, that will be 140. All right, so once you have this arc, the arc AC, 140, so we can also have the semi-inscribed angle. Remember that the semi-inscribed angle is the arc divided by 2. It's half the arc. So it will be this angle X. The angle X will be 140 divided by 2. So that will also be 70 degrees. All right. In this case, we also have 70 degrees. Okay, guys. So these are the semi-inscribed angles, guys. Remember that these formulas are really easy. If you multiply by 2, the inscribed angle, if you multiply by 2, you get the arc. In the semi-inscribed angle, is the same case. If you multiply by 2, you get the value of the arc. Okay, and vice versa. If you have the arc and you divide by 2, you will get the value of the angle. All right. So guys, I hope you really understood. See you next class. Bye bye.